So what would you guys say is the biggest challenge today in board design, right? As we pack more and more layers together, you got high-speed signals running around left and right. Things are getting denser and denser. How do you guys work through that?
I guess the big technology now that we're using more and more is the stack via technology with the smaller line widths, and now I guess the new materials, the dielectric thicknesses and things like that. So it's just density. It's the I/O continue to go up on the BGAs mostly, and then they get smaller and smaller as far as the overall package size. So you're just forced to go to different via technologies more and more. Which, unfortunately, I've been doing this for years and years and years, and they always told us that the auto routers would keep pace with the new technologies, and you do more hand routing now on circuit cards than you did 15 years ago.
Really?
Yeah.
Talk to us a little bit about your competitive landscape internationally, right? There's always the fear that Asian board manufacturers are going to take over the world, but then the reality of it is that they're usually a generation or two behind. Is that true, or is that?
The high technology stuff, the cutting edge stuff, we still go to the United States. You go to the DDIs, the TTMs, the VIA systems. Those guys are the cutting edge guys. They really are. Any new technologies, they were the first with the stack vias. They were the first with the laser via stuff. And you can still get stuff in 3 days.
Right.
And customers always want that. Yeah, you can save money by going to Asia, but you can't get a high-tech board turned around in 3 days in Asia. You just can't do it, and bring it back here.
Manufacturing does seem alive and well in the United States, not at the consumer volumes,
right,
but at specialty applications, industrial, military, that sort of stuff. We're doing pretty well.
Yeah, I actually worked in China for 2 years, so I'm kind of familiar with what works well there and what doesn't. And clearly, cell phones, for example, where you're building millions and millions of them, that's a good fit for Asia. But your medium volume and your lower volume products, when you add in all of the costs of logistics of shipping things over there, if you have a problem and you need to fly your engineer over, the cost and the time. I mean, I used to do that flight all the time. You'd be 32 hours from door to door to get over to your hotel from your house when you travel. So, and the cost, there's a lot of cost when you do that. And if the product is, a lot of the products aren't that labor intensive, as you can see from our facility here. It's a lot of automated placement and so forth. So if there's not a lot of labor in the product, we can get the materials for the most part pretty much the same price as you can in China. So we are seeing some companies starting to move production back into North America from Asia, where they don't have the volumes that justify the extra expense of supporting an offshore facility like that. In fact, we're on a call with a customer this afternoon at 3 o'clock, where they're currently building in Taiwan, but they're really interested in having the product built in the United States. There are other considerations as well. If you've got military products or certain products that have to be manufactured in the United States, then that's another advantage as to why you would do here. And when you get into really low volumes, 100-piece builds, 200-piece builds, it just, the engineering work to go try to set something up like that in Asia, it just doesn't make sense.
Were you getting any quality feedback from these people who are onshoring now that they weren't satisfied with the quality in addition to the logistics issues?
Well, yeah, I think it's widely known that for high volume, the Far East, Asia, they can do very well in high volume, where you're just building the same thing over and over and over again. But in a lot of cases where you're building a high mix, low volume product, a lot of times you're not going to get the quality out of China. And one of the things that I faced when I was in China was, you've got different tier suppliers that you're using, and you've got your international firms that are in China, and then you've got your your kind of higher class, Chinese companies, and then you've got these dirt cheap companies, and of course the pricing goes all over the map. And with the dirt cheap guys, you expect you're going to throw away 10% of what you get is no good. And even in that middle tier, we found you had to watch out, because you might specify a certain metal to be used, and the supplier doesn't really think that it's that important, and they switch and they use something else, not knowing the intricacies of your product, and now all of a sudden the product doesn't work. So the way we combated that, we put an army of supplier quality engineers in place to be able to deal with that. Of course, that adds cost.
So when you guys started, when you expanded into contract manufacturing in 1984, from then until now,
2004.
right? 2004, sorry. So 7 years. Are you seeing, is this a definite trend that people are pulling back to do manufacturing at home, or did you see it then as well as you do now?
Really, 4 years ago, it was like everybody, it just seemed like it was a feeding frenzy where everybody thought they had to go, either south of the border or to Asia. And even, lower volumes in the single-digit thousands, they were going to Asia with, and we see those customers coming back now.
Okay.
Yeah. So, it has changed. It definitely has changed.
That's good.
We've also seen some of the mid-tier and smaller EMS companies that tried to set up something in China, for example, and it just didn't work out, and they've pulled back and they've closed down what they had set up in China. It just didn't make sense. And again, it ties into, it can work if you're doing millions of something in high volume, but in the medium and lower volume space, I'm not going to say that nobody can do it successfully, because there are some companies that will put the high overhead and the high resources in place to try to do well in that space, but they're few and far between.
Tell us what your hot technologies are.
Okay, well, we've got two MyData lines. We really like the MyData for the high mix, low volume because of the way the feeders are, the quick changeovers that you can do. We start out, we've got the MPM screen printer that's got a 2D inspection for paste deposition, so we can check and make sure after we put the paste onto the board that we got good paste deposition onto the board. And then of course we go into the placement machines.
Where's MyData based?
MyData is based out of Sweden, is it?
Okay.
Yeah. In fact, you see there on the wall, worldwide built in Sweden. And their product really is good for your high mix, low volume. Although they do have some equipment out now that is also, geared towards higher volume products. But one of the things that I really like about this equipment is that when we're setting up for a job, you can scan the reel on the component, and then you scan the feeder, and then you can put the feeders in anywhere you want, and the machine will know where to go to get the part and put it and make sure it puts it in the right place, so you don't have the problems of accidentally putting the wrong part on a board. Now, we don't do random setup like that. Maybe on a short job of 10 pieces we'll do a random setup, but for the bigger jobs we'll do a what they call it, a optimized setup, where the higher running parts they'll put closer to the where the board is, so the travel isn't as great. Yeah, we've got some, if you've got a small job on the machine, you've got another small job coming, you can put the second job on the machine while the first job is still running, and then the changeover is a matter of minutes. Just to, if you have to change the conveyor width and change the oven settings for the reflow profile, and change the stencil out on the screen printer.
How many employees do you guys have?
125?
Yep, 125.
Okay. And you're, I think you mentioned you're growing like wildfire.
Yeah, we've
That's
experienced
a couple good years
triple-digit year-on-year growth, so we're doing really well. And it's been a real nice, positive, continual trend.
What's your biggest challenge? Thing that keeps you up at night?
New business. Yeah, because you're always thinking, no matter how good it is right now, you're always thinking about what's coming next, what's going to feed it. Is there going to be a drop off? So for me, it's always sales.
Always sales. And how about technologically? Are there technical hurdles that you see either with the software that you guys use or the challenges that customers are presenting you that that
well, right now,
keeping you up at night?
Right now we're looking at getting into package-on-package technology, and we've been able to do lower volumes. We could do 10. In fact, we've done up to like 50 pieces of package-on-package. I'm not sure if you know what that is, but that's basically where you have excuse me, you have a ball grid array that goes on the board, and it's got pads on the top of it, and you put another ball grid array on top of that. And the technology advantages for that, and it's generally you'll see that like in cell phones where you've got really tight spacing requirements. Also where you want low power consumption so you're not draining your battery, because the travel then, they'll put the processor down first and then they'll put the memory device on top of that. So the battery drainage, the power consumption, the heat and so forth is much less in that type of an application, and the density and the spacing that you're able to get. So you're seeing that a lot in your real high volume cell phones and things like that. We're starting to see it coming into this medium volume space because of the performance advantages. So we're looking right now at adding some capability to be able to do medium volume, hundreds, thousands of units with the package-on-package technology.
What's the most complex board that you guys do? 6, 8 layers?
I want to say 27 or 28 layer,
28 layers.
over 10,000 components. It's a monster. In fact, they've been really pleased. They didn't think, we designed it here as well. That was a bear of a design. And I think the agency didn't really even think that it was going to be possible to do it in the space and size that we were able to do it in. And so they're very, very pleased with that product.
28?
Yeah. This is a product that we're building for the Virginia Tech Transportation Institute. It's a pretty cool product. The National Transportation Safety Board is doing a study. They're trying to understand, why so many Americans get killed in automobile accidents. And so what this product does is this product ends up getting installed in vehicles. And there's like 2,000 vehicles out there that have these units in them where there's a camera looking out the front of the car. There's a camera looking out the back of the car, and it's pretty close to 180-degree view, so you kind of pick up stuff coming from the side. The camera also on the driver's eyes and face to see what they're doing. Camera down on their feet to see what they're doing down at the gas pedal and brakes. There's a radar in the units. There's a GPS system in the unit. And there's also an alcohol sensor, so they can see if there's alcohol. And what they're doing is they're putting these devices in automobiles for 2 years, and they expect, this is a bit morbid, but they expect that there'll be seven fatalities during the 2-year study out of these 2,000 cars. And so then they can dissect and understand exactly what was going on when this accident occurred.